All right, so to review what we did last week, this is where we left off. We left off by creating a function called sumnums, and we did it using the specifications that I gave you guys. So the first specification was to define a function named sumnums, and we did that. So where the function name is what the function is called. It should be descriptive of the function. It should kind of tell you what's going on, and also probably short, so you don't have to have like a huge line, but more descriptive, the better. And that is right here. This is the function name. And also that's how you call your function. So remember when we have like pow and we say, pow's a function, by the way. So we say pow and we say 2 to the power of 3. What we have written right here is called a function call. And when you write your own functions that we have up here, this is our own function, we have to tell it to run. So this is something that's kind of new. Normally, when we have code thus far, it was all in this thing called main. And when we would do our program, we would just go from the top of main all the way down to the bottom until we hit the return statement and exited the program. Maybe we'd move around using some loops or some if statements, but the entire time, everything was in main. But this is something new. We have these things that are called functions, which happen outside of main. And why are we allowed to do this? Well, the first thing is to note main is a function. And you can see all the parts of a function here. We see that main has a return type. Look, int. That's where your return type is. In addition, main has a name main. There's your name. And it has parentheses right there. And this is where your parameters would be if it had any. And finally, look at that. It even has a return statement. So main has everything it needs to be a function, and it is a function. It's just a very, very special function that every single one of your programs in C++ will have. So just because we are creating like all these new and exciting functions doesn't mean we can forget about main. Main gets special privileges. It's fancy. It's special. Every single one of your programs will have main. And main is the function where all of your code is like starting from. So whenever we have a code like this that has multiple functions, when we are going down the list of the compiler, we'll include like the libraries. We'll say using namespace std. This is a comment, so we don't care anything about that. And then we'll come to this function. And it's going to say, okay, I see a function here. I'm going to define this function. I'm going to know, okay, if anytime later in the program, we decide to call sumnums, I know it exists, but it's not really going to do anything with it. And then it's going to go all the way down. It might go through a few more functions if we happen to have them. And then it's going to get to main. And every single time you have a program, it's going to actually start from main. So when we like start running code, the first thing that the compiler is going to do is whatever the first statement in main is. It doesn't matter how many functions we happen to have up here. It always goes to main first. So if we look at the flow of a program, we are going to go to main, and then we're going to declare 3 type doubles. And then we have right here a cout statement, which invokes a function call. That's this part right here. This is a function call. And that's the only thing that tells your function, okay, it's time to run. That's what tells your function, let's execute some stuff. If we never called the function, it's never going to run. So we have to call it. And then when we do call our function, what happens is these arguments right here in a function call, these things are called arguments. They are sent up to the function. So whatever the value is in user num1 gets sent to the equivalent parameter in the function. So this gets sent here, this gets sent here, and this gets sent here. Then the function is going to take those values that it got sent, those inputs. It's going to do some stuff with them right here. And then it's going to hit this return statement. And as soon as the function hits the return statement, it says, okay, whatever I have just calculated, I'm going to send that stuff back to the function call. And that's what the function call results in. So we can see this with pow. So when we have pow, we say 2 to the power of 3. And this invokes the pow function to actually run. So in a library somewhere, when we have CMath, there's a certain section of that file that has the pow function defined. And what's happening is we're sending this 2 to the pow function. We're sending this 3 to this pow function up here. The pow function is going to do some stuff with it. And then it's going to finish its calculations, hit a return statement. And then whatever the value it's returning is what the whole function pow results in. And then we come back to pow, and then we continue on with our program. So that's where things are moving in the program. I just wanted to briefly cover that because we haven't talked about things outside of main. The only other thing I wanted to talk about with this particular function, because I know we wrote it last week and we already know a bit about this one, but the parameters to argument equivalent is determined by the order that they are listed in rather than the names. So let's say that if I switched usernum 3 with usernum 2, it's not going to match these names because honestly, it doesn't care about the names. It only cares about the order. So this one matches to the first one, the middle one matches to the middle, and the last one matches to the last parameter. So it's the order rather than the names, which depends which goes where. And that's about it for this function because we already talked a lot about it last week. I don't want to talk about it too much more. Any questions on this before we look at another one?
No, it looks good.
Okay, cool. So that is that function. We wrote that ourselves last week. So the next thing that we're going to do is we are going to look at some function terminology. So this is something that you might see on a exam or just honestly some good things to know. So the function is made up of a lot of different moving parts and they all have a specific name. So the entire function itself, like the return type, the name, the parameters, the body, the return statement, all of that thing is called the function definition. So in our previous code, all of this stuff is the function definition. Then we have the function call. So that is where we invoke the function to run and we send it its values that it's going to take. The other term to know is a return statement, and the return value is what the function ends up resulting in. So when we have pow and we have 3 to the power 2, the return value is 9 because when we say cout pow, this whole expression here resulted in the value of 9. Finally, you have your parameters. This is where the inputs go in the function. And lastly, you have arguments. And arguments are what is in the function call and passed up to the function itself. And we're going to look at a new function, and I will show you guys. Actually, you guys are going to tell me in this particular code the answers to all the things in the comments. So we have another function here. It looks very, very similar. It honestly is almost exactly the same, just some new numbers. But you guys are going to answer these things in the comments. So the very first question is, what is the function's name? And you can type in chat or just say it out loud, whatever works best. Exactly, the function's name is sumnums. Perfect. All right, what is the function's return type? Exactly, the function returns a type double, and we know that based on this return type specification there. All right, where is the function call? So what line number? Exactly, yeah, 13. The function call is defined as where do we tell the function, okay, it's time to run. It's time to go do your stuff. That is exactly on line 13. You are absolutely correct. All right, next, where is the function definition? So just give me a few line numbers, a few or one or however many. It is from 4 to 6, actually. The function definition is defined as everything, basically, that involves the definition of the function. We got to define what the return type is. We got to define the name. We got to define the parameters. Then we have the return statement. Maybe we'll have like some other code in here. Very fancy code, I know, but maybe we'll have some other stuff. And it's just everything. It's from the very start of this all the way to the final curly brace. So that is where your definition is. So that would be on lines from 4 to 6. All right, what are the parameters of the function? Also interrupt me whenever if you have any questions on any of these definitions. The parameters are, so this is the kind of the arguments almost, what's happening there, because that stuff is happening in main, right? we have defined some variables. These aren't technically the arguments yet. They're the arguments once they are in this function call. Now they're the arguments. And the arguments happen in the function call. It's the stuff from where it's called that's getting sent up here. But the stuff up here, all of this, these guys are the parameters. A little bit of a technical thing, but I thought we should cover it. So the parameters in this particular function are num1, num2, and num3. Hey, Samantha.
Hello.
Hi, we're just going over some definitions of a function, what everything is defined as. All right, so I just covered what the arguments are. What are they? Which are the arguments?
I'm gonna have to take a look again because I kind of forgot a little bit about functions.
Oh, it's okay. So on these slides, we have some definitions of everything in the function, and it tells you what everything is. So basically the entire function itself, like all of this, is called the function definition. Where we invoke the function to run is the function call. This data type in front of the function defines the return type, and the parameters are the stuff in the parentheses in the function definition. So the next thing we're looking at is the arguments. So the arguments are what are appearing in the function call. So it's this stuff right here. It's user num1, user num2, and user num3. 1, 2, and 3. And so that stuff is what's getting passed up here. But if you were looking at the value itself, what would get passed to num1 would be 12. What would get passed to num2 is 11. And finally, what would get passed to num3 is a 9. So that stuff is getting assigned to these variables, which are the parameters. And then your function has those like pre-assigned variables that it can work with and then do some calculations with and send back. And I have just defined this, I guess. So the value that gets passed to num1 is a 12. And this is defined as not necessarily the name of the argument versus the parameter, but the order. The first argument gets sent to the first parameter and so forth. So the middle one gets sent to the middle and the last one gets sent to the last. All right, so this would be 12, 11, and 9. All right, 2 more questions. What is the function's return value with the specified arguments that we've already given it? 32. And finally, how can we print this value that Joe says is 32 from the function? Because right now, actually, if we were to run this, call it function, and I ran the executable, we don't get anything coming back. Well, what happened? We called the function. We told the function, hey, you got to run. So obviously, we jumped from main up to this function here, but it never printed anything. And James says to use a cout statement. So there are actually multiple places where we could use a cout statement. So the one that you're probably most familiar with is we have a function and we're going to just print it just like that, kind of like what we do with POW. And this should most definitely work. Let's see. There you go, 32, you got it. All right, awesome. So that is one way that we could print a function's value. Another way that we can do the exact same thing, this is going to require a little bit of reworking of the function, but it's called using a type void. So usually when you guys have seen functions thus far, when you call them, they kind of result in some value. So if we were to call like abs, the absolute value function on -9, and if we were to have that CMAF included, I'm not going to do it because it's just an example, but if we were to print this, we would expect to see a 9, right? Here we saw a 32. When we use POW, if we print it, we see some sort of value. And that value is coming from the return statement. However, there are some functions where you don't have a return value. And this is when you use what's called a type void. So void kind of means absence of, so you can think of it like that. When you don't want to return anything, it's type void. So This is now illegal syntax. We can't have a return statement with a value in a type void function. So we can't do that. But what we can do is, remember when I told you that main is a function? So anything that we can do in main, we can do in our functions, because main is just a function. So we should expect that we should be able to create variables in our function. We should be able to do for loops, if statements, print statements, input statements, basically anything you can do in main, you should be able to do in these functions because main is function. And that is 100% true. So another thing that you could do here is you could use a cout statement and then print your numbers like that. So, and a type void can have a return statement, you just can't have a return value. So what the return does is at the end of the function, when it finds this return, it actually jumps back to the function call. So I'm going to prove this to you guys. So if we say cout right here, we shouldn't expect to see this get printed to the console because we had hit the return statement one line previous. So let's take a look at this. So I'm going to remove the cout statement here. And now we just have a function call. So this looks a little bit weird because we're calling a function and we're not really doing anything with it. Well, the reason is the stuff like the action code, like the stuff that's happening is happening in the function itself. So now this works exactly the same. We send user num1 to num1, user num2 to num2, and user num3 to num3. Then the next statement that it sees in our function is a cout statement. And this is going to just print the sum to the console. And then we're going to hit a return statement. And whenever we hit a return statement, we jump back down to the function call. And that's it. That's all that's going to happen here. So let's prove that. So I'm going to go ahead and run this program one more time after saving it. No errors. And there we go. We got 32. Basically the exact same output as before, but this time using a type void function. You probably wouldn't end up using a type void function for something like this. Type void functions can be good. Maybe if you have a cout statement or something that you're just like repeatedly using over and over and over in the code, you don't want to keep typing it, we can stick it in a function. We can just put that in a function and then save it for later and just call that function again. And the reason why we didn't see the hello world stuff is we had hit that return statement and jump back to the function call. But if I were to move this above the return statement, there it is. So do you have any questions on all of these definitions before we do like some actual coding again? Or does this all make sense? Pretty technical stuff. This is more exam prep in a way. But any questions? All right, so our next exercise is a shorten the code exercise. So I have this code here that I have written. It's like 50 something lines long, but you probably see a lot of things that are repetitive. And when we see stuff that's repetitive, a lot of times we think, can it go in a loop or can it go in a function? And spoiler alert for this one, these ones are going to go in functions. So your job here is to take this really long program that I have and try and shorten it into the least number of lines possible while following good coding practices. Because I know that I've previously discussed with you guys that technically with C++, you could write everything on one line and be fine. So like the semicolons are what are separating your statements. So you can do this, but we're going to stick to good C++ style and have one statement per line. And you're also going to stay under 100 characters per line. And do you guys want to do this individually and kind of see what you guys can do on your own and then compare who got the shortest code, or do you want to do it all together in groups? Didn't really know how you'd want to do this one. Any opinions? Yeah, this is the original code that we have here. And it's pretty simple. It just calculates the weekly salary for 3 different workers. And if we were to run this program, you would see that happen. So we do G++, run it. So that's all the output that you should be seeing. And our job is to shorten this code, which is 51 lines, into a lot shorter. I was able to get it into 15. So altogether? All right, so we have 1 vote for altogether and 1 vote for group. So I need 1 more person. I can put you guys in pairs all together. Okay. Alrighty, so you guys are going to tell me what could I do to this program that is going to make it a lot shorter. And the hints that I have given you is it's going to be involving functions. Resuming the recording. So we finished our shortening the code. We were able to get it down to 15 lines, and you can see this on the SI Canvas page if you want to see the original versus the shortened version. So now that we have finished doing that, our next job here is to write some more functions. So we're going to get some practice with that. And we are going to be recreating the CMath functions. And I have listed here some cout statements. And basically these cout statements, this should result in 81. This should result in 27. This should result in 9. And 9 to the power 2, also 81. So we are going to write the functions that are going to allow us to have those cout statements work as I have just showed you guys. So let's start off with the squared function. Who can tell me what I'd want to write for that?
We can start by creating the function, and we can, yeah, kind of like what Joe said.
All right, Joe, that sounds perfect. So we're going to do int, and then we're going to do, so our function call here is called squared. So we know that whatever function that we're trying to call, its name has to be squared. And this is something I actually ran into last year with SI. We tried to make it like the exact same names as the CMath functions. And the compiler got all kinds of confused because it was expecting CMath and we had like our own. So I made them different this time. So we're going to do squared, and we need, do we need parameters? 2 parameters. Okay. What do you think those should be?
Oh, no, I take that back.
It's okay. It's okay.
It'd just be like 9, like one of them, like 9.
Yeah, we could say int, and we could call this anything that we want. So I'll just call it num. And now we are good. We have an int return type, we have a function name, and we have parameters. So that checks off the header for the function. And now all we need is a return statement. So what do we want to return?
Num times num.
Perfect. Num times num. And now I'm going to save this, and we'll uncomment one of those cout statements and see how we did. Functions. All right, no errors. A.out. Perfect. There we go. We got 81. And we can test it with another number. So if we did 3 squared, we should expect to see a 9. And there it is. Perfect. That works fantastically. All right. Next, we have a cubed function. This one's going to be very similar. So since it's so similar, I'm going to just copy and paste this, and we can change the name to cubed. And instead of returning num times num, we're going to return num times num times num. And that should take care of that one. All right, there we go, 27 as expected. All right, help me out with the absolute value one.
Well, it'd be int absolute value.
It's going to be int absolute because we got to match the name, but very good. All right, what parameters do we need? Well, a nice handy little trick is we see that we're sending it one thing, right? So we know that this one thing needs a place to go. Like whatever we have here has to go somewhere where we're sending it. And how you define where it goes is with the parameters. So we are sending it one thing, so we should have the ability to intake one thing. So I'll call it num. All right, so now what do I want to do inside of this function?
Return the absolute value.
Yeah, but how do I calculate that? I mean, I could use a CMath function, but we're trying to do it ourselves. If I gave you a negative number, just hypothetically, what could you guys do to it that would make it positive? Because that's basically what we're doing here. If we send the absolute function a positive number, we want to do nothing and just return the positive number back. But if we send a negative number, we want to do actually something else. What could I do to any negative number that would give me the positive equivalent?
Negative times a negative.
Exactly. So we know that we are going to take in num, and then we are going to multiply it by -1. and that should make it positive. But we kind of have a condition here. If it's positive and we multiply it by -1, well, then we're going to end up with a negative number. So what do you think I could do to make it so we only multiply by -1 when we have a negative number?
An if
If
statement.
Perfect. We're going to say if, and then we are going to say if num is greater than or equal to 0. We're going to call stuff like that positive, because if it's 0, we just want to return back 0. Or if it's greater than 0, we want to return back the positive number, just the regular positive number. So what we're going to do here is exactly what we're going to do. We're going to say return num, and that's it. Then if it's not 0 or greater, it has to be negative. So we'll use an else statement. And then we're going to do what we just said here. So we're going to do return num times -1. So this brings up an important point here, that we can have multiple return statements inside of a function. And this works just fine because they're all in the decision-making statements. So no matter what number they enter, as long as it's like an integer number, one of these clauses is going to run if it's greater than or equal to 0. So like we have our number 9 here, and here's 0. So if our number that they send in is greater than or equal to 0, so if it's from here to here, we know that we're going to run this first statement. And what's going to happen is we're going to just hit this return statement, return num, and since it's a return statement, we jump back to the call of the function. And that's it. This other stuff doesn't even happen. So it doesn't matter to us there. Then if we send it a negative number, so if we send it a number from here over, then what's going to happen is it's not going to be greater than or equal to 0. So we're going to move to the else statement. And then we have a return statement that says to return the number multiplied by -1. And this earlier one, we never even see it. Does that make sense? Why we can have 2? You just want to be careful that you include all the range of possibilities. Because if I did this, then that would be an issue. Because now, if we were to send the absolute value function as 0, well, the 0 is going to get put into num. And then it's going to say, oh, wait, no, that actually wouldn't cause an issue. We just multiply 0 by -1. Never mind. But if we had like an else if and said num is less than 0, then we would have an issue, because we're saying is num, which is 0, greater than 0? This is false. Is num, which is 0, less than 0? This is false. And we reach the end of our function without reaching a return statement. And this is going to cause some weird stuff to happen. It could either cause the compiler to just pick a random value for you, or it will give you an error. And in either case, that is not fun for us. So you got to make sure that your if statements are actually inclusive to all potential values. So going back to what we had that, and running that code, we see a +9. And if I were to give it a +9, we want to make sure that the previous stuff works as well. There we go. We still are left with a +9. So perfect. Any questions on the absolute function? Or does that all make sense? All righty, feel free to interrupt me. Oh, Samantha, you do have a question, or it does make sense?
No, I don't have a question. I got that.
Cool. Alrighty, so now we know we're allowed to have multiple return statements, and we also can see that we are allowed to have logic in these functions, just like I told you guys earlier. And the last one is this power function. This one will honestly take us probably 15 minutes. Do you want to do the power function, or would you like to finish off functions for today, and then tomorrow we'll just start off playing with vectors? Because we have one last thing to talk about with functions.
Finish functions.
Finish functions? All right. So power, it uses a for loop and some weird for loop logic. So if you want to do it on your own, totally go for it. I will post the answer to the power function when I post these codes. But for now, I think we have a good idea of how to write and define these functions. And the very last thing that we need to talk about with functions today are what's called passed by reference and passed by value parameters. So basically what happens, this 9 is in user num, and then we call double user num, and user num has the value of 9. And what happens here is we get sent to this void function, num gets sent 9. And so now num has the value of 9, and this is the exact same statement. If you guys don't remember, this is num is equal to num times 2. There we go. We're trying to manipulate the parameter. And I think the programmer's intention with this program is that when they would next use user num in their program, it would be doubled. So they're expecting that it would print out an 18. But I want you guys to notice something when we run this. There it is. And I run the program. And I enter 9. So here's what's happening with the program. We start programs with functions. Even though we have so many functions, it just defines them, but it doesn't do anything with them. Then we hit main. And then we have a variable declaration, pretty simple stuff, some cin statements, and then we have a call to our function. And the call to the function is going to send 9 up to our function. It's going to do this stuff to num, but it's not doing this reinitialization of the variable to user num. So what ended up happening is user num didn't get changed. Basically, when you have a function, it sends a copy of the value to the parameter. So it has this 9. User num has a value of 9. So it's taking that 9 and sending it up to the function, and that 9 is getting assigned to num. And these variables are completely independent to each other. So we could do whatever we wanted to num in the function, and it's not affecting user num, which in some cases is pretty advantageous to us because we can manipulate some numbers or some variables and still retain their original copies. However, in this particular case of this program, the programmer expected that user num would get sent up here and we'd double it. And then after calling this function, they'd be able to print out their number doubled. But we can see that they still have a 9. And this is called pass by value. A pass by value parameter is just the regular parameters that you are familiar with. When you send something to them, it essentially creates a copy, can do whatever it wants with that, but the original stuff from the call is not altered. But there is a way to alter the original variables in the function call, and that is called pass by reference. So sometimes it's important to us that our function can modify the original arguments that we send it. And this can be important when you want to, for example, return multiple values from a function. When we have a return statement, we can return one thing back to the function call, but there are some cases where maybe we need more information from that function. Or maybe we want to send it, for example, a string, and we want to send the function a string. Maybe the function's called capitalize all letters or something, and we're sending it a string. But what if we want, when the string comes back from our function, all the letters to be capitalized? Maybe we want to modify something. So that is when we would want to use something called a pass by reference parameter. And pass by reference parameters allow you to modify the original value of the arguments that you're being sent to the function call. So this program that I have just showed you is probably not good coding practice, because when we can use a return value, we would like to. So this program could have been much better written by me if I had said double and then just returned num times 2. This would have probably been how you'd write the program, but if you have more advanced stuff, there are going to be cases where you can't use a return value. And this is when you're going to use a pass by reference parameter. And the good news is they're actually pretty simple. The only thing you need to do to change a value parameter to a pass by reference is just add an ampersand on the end of the data type. And this allows you to modify that parameter or that argument inside of the function. So let's see how that works. So what you're going to do is you have our code here. This is the original one that was printing 9. All you have to do is whatever parameter you want to become a pass by reference parameter, you put an ampersand, and that is it. And now if I were to run this, 9, your number doubled is 18. So that's the difference between pass by value and pass by reference. Does that, any questions on that? Does it make sense why there's a difference? Okay, cool. I am glad that that makes sense. Not too bad, I think, but something we got to bring up. So yeah, and you could have a mixture, just to point out, of pass by value and pass by reference. And this is totally fine. We can have some pass by reference and some pass by value. You just got to make sure you're putting the ampersands on the correct one. And that is it with this pass by value versus pass by reference. So it is 3:30, which means that we are officially done with SI. So tomorrow we will start talking about vectors, and these are really cool, actually really fun to work with. They can be a little confusing at first, but we'll talk about those, talk about different functions that go along with them, and do a pretty fun program with them. And that is it for today. So I will let you guys go unless you have any other questions for me, and have a great rest of your day, and I will see you tomorrow.